Yeah.
Yeah, sure. Yeah.
What I know we have to pass the final with a certain percentage, but what percentage for the homework do we have to do that to pass?
70%. 70.
Okay, thank you.
Yeah, sure. Okay, yeah. Any other questions? We will talk about the last five sections, right? Just five more sections. And first of all, let's talk about the section 7.1. So, one note. So section 7.1, that's only thing we're gonna cover in chapter 7 and also chapter 8, right? About the radicals, and then that's all. After that, we're just gonna review for the final exam. And we're gonna start a review tomorrow. Share the screen with you. Okay.
Professor, there isn't a chapter 7 and 8 on the homework, right? It stopped at 6.7.
I haven't assigned it
You have
yet.
to upload it. Yeah.
Okay, all right.
I will assign it shortly, right? Don't worry. Yeah. Yes, because we haven't covered anything yet, so I haven't assigned it yet. But yeah, I will assign it for today, right? For sure. Okay. So chapter 7 is on rational expressions. And basically, we apply some factoring skills to simplify the rational expressions, and that's what we try to do here. Rational expression. So to reduce, so the rule is in order to reduce the rational expression, reduce a rational expression to the lowest term. The lowest term. And basically, we just factor the numerator and denominator and then cancel the common factor to the numerator and denominator completely. And then cancel the common factor. Okay. Cancel common factor. So most important skill here will be factor, right? And we talked about the factoring yesterday. So actually we can review a little bit today. So whatever you learned yesterday, you can use it, to simplify the rational expression. Let's start with some simple ones, right? Let's say you get let's say x squared minus 9 over x squared plus 5x adding 6. Both top and bottom, right? On the top is what we call the difference of two squares. We do x squared minus 3 squared. On the bottom, this is what we call the trinomial, right? And we learned how to factor trinomial yesterday. To break down x squared as x times x. And then we're going to break down 6 as positive 2 times positive 3. Because when you multiply them, you get 6. And you add in them, you get positive 5, right? So this is kind of shortcut to check the correct combination here. And also we can double check by cross multiplying, right? Positive 2 times x is 2x. Positive 3 times x is 3x. Combine them, you get positive 5x, which is exactly the middle term. That means we get a right factoring, right? X plus 2, x plus 3. On the bottom, on the top is the difference of two squares, so the x plus 3, x minus 3, so over x plus 2, and x plus 3. Now we see the common factor, right? The common one, which is this. So cancel that. And then the remaining terms would be the answer, x minus 3 on the top, x plus 2 on the bottom. Any question about this? Okay, so let's look at the second example. Let's say we get something like 10a plus 20 on top. On the bottom is 5a squared minus 20. So first of all, we always start with the GCF, right? Factor by GCF if possible. On the top of the GCF is 10. Okay. So factor of 10, we get a plus 2. On the bottom GCF is 5. And we get a squared minus 4. And from there, so step 1, always check the GCF, right? And then after that, we factor by whatever applies here, right? So in this case, the bottom difference of 2 squares, 8 plus 2. On the bottom, that's 5 times a plus 2, a minus 2. From there, we just cancel a plus 2. Then also 5 going to 10 2 times. So the top 2 remains. On the bottom, a minus 2 remains. That's a typical question on a rational expression. And one more, right? Before we move on. So let's say we get something like x minus 5 over x squared minus 25. Like the factor, the denominator is the difference of 2 squares. The x plus 5. 5 on the top is x minus 5. We cancel the common factor. So the answer is x plus 5. Is that right? What do you think? The answer will be 1 over, right? 1 over this. Because when you cancel the common factor, there's an invisible 1. So this is a very common mistake. A lot of students make mistake here. So just want to point out to you, the answer should be 1 over x plus 5 here. Any question about this? Let's take a look at let's try a couple, right? Let's try a couple. First one, let's do x squared minus 10x, adding 9 on the top. On the bottom is x squared minus 9x. And second one, it's going to be x minus 2 over x squared minus 4. And then the third one, would be cube plus 3x squared minus 4x on the top. On the bottom, x cubed minus 16x. So I'll let you guys try this really quickly. Okay, guys, let's go over solution. For the question one, we get a factor both top and bottom. For the top, we will factor trinomials, right? So it will be put it down this as x times x. And then break down positive 9 as -9 as -1. -9 times -1 give you +9. When you add in them, you get -10, which is middle coefficient. And we can double check cross multiplying minus not x, 1x, that's -10x. That means it's good. So x -9, x -1. The bottom factor by GCF. GCF here is x, so put x in front, the x -1. All right, now from there, we just cancel the common factor. This one will cancel it. And the answer is x -1 over x. That's the answer for the first one. Second one, factor bottom is the difference of two squares, x plus 2, x -2. Now again, we cancel the common factor and put back the invisible one. Right? That's very important. So it's 1 over x plus 2. And so that's a question 2. Question 3, you get a factor by GCF first. Top GCF is x. Bottom GCF is also x. So factor GCF out first. So factor out x. You get x squared plus 3x minus 4 remains inside of the parentheses. For the bottom, when you factor out x, now we get x squared minus 16. The top is a trinomial, so we're going to factor as x. And it's going to be +4, -1. Multiply them, you get -4. Adding them, you get +3. So you can also double check by cross multiplying +4x minus 1x. That is +3x. And that is exactly in the middle term. So it will be x plus 4, x minus 1. X minus x plus 4 minus 1. On the bottom, again, x carry over x plus 4. Now here we start canceling, x get cancelled, common factor, x plus 4 get cancelled. Then we end up with x minus 1, x minus 4. Yep. Any question about this? All right, so we're gonna go back to the webbook and let's look at some exercise on the webbook. Let me log in first. I'm gonna assign that assignments to you guys right now. And then assign those 5 assignments, 7.1. So you should see 7.1 right now. Let me assign the other. Okay. It's assigned, and then 8.1, 8.2, 8.3, and 8.4. 8.1. Let's see, 8.4 here, 8.1 is here. And assign that. And 8.2. Sure, so assign that as well. it should be labeled 8.2. I think the labeling is not right, but it's okay. Yeah. Just remember to do all this work, that's all. 8.4. Let me see if any 8.3 here. Nope, yeah, so that's all actually. Yeah, only 4 more assignments. And let's look at the 7.1 first. 7.1. Yeah, reduce inversional expression to lowest term. Okay, so let's take a look at it. Question number 1. Okay, you guys try this really quickly. So while you're doing this, I'm calling attendance. Sign to the sheet. I'm calling attendance right now. Mariam,
Here.
wait. Alexandra.
Here.
Okay, good. Bianca.
Here.
Bianca. Okay, good. Um, Mirza. Ashley. Benjamin. Kareem.
Yeah.
Okay, great. Anahi.
Here.
You good? Maya.
Here.
Okay. And then Sarah.
Here.
Okay. Okay. And Jonathan.
Yeah.
Mhm. Okay. Very good. Enta. Enta. I did mark you three, right? If I see your name on it, so I mark you if you didn't respond. Let's go back to the question here, and then let's go over solution. So here, factor the top is the sequence of two squares. So this is going to be x plus 5. The bottom, I factor by GCF 378. X plus 5. After that, we cancel the common factor. X plus 5 get cancelled. The answer is x minus 508. Any question about this? So bx minus 5 over 8. Submit it. Okay, correct answer. Let's try the second one, right? We're going to factor the trinomial on both top and bottom. Let's see if you can do it. Let's go over solution. So top, we should put down as x squared become x minus 27 should be positive 9 and 3. Because when you multiply then you get 27. When you adding them, you get positive 6x, positive 6. That's what we want. And because multiplying, right, we get positive 9x minus 3x, that's positive 6. And that matches in the middle term. So first term here, last term, middle term. All three are confirmed, right? So the factoring should be 9 x minus 3. On the bottom, again, it's right down top. The first term, x times x. Last term will be positive 9 times positive 3. 3 times 9, 27. We add them to positive 12. That's what we want. And we can double check cross multiplying positive 9x plus 3x because positive 12x middle term. First, last, and the middle term all confirmed. We get correct factoring x plus 9, x minus 3. No, x plus 3. No, minus 3. And we cancel the common factor, right? There you go. Then actually we end up with x minus 3 minus x plus 3. Any question about this? Minus 3 over x plus 3. On the bottom, submit it. It's the correct answer. Ax squared minus 50. Or x squared plus 10x minus 50. Let's skip this one. 12. Yeah. Hold on, right? I'm not gonna go over. I'm just gonna drop a couple questions here. It's not a proper question for you guys, so I'm gonna drop it. But first, second one is good. Third one is okay. That's out of 4. Definitely not fourth one. Not fifth one. The sixth one is okay. Okay. So let's go back and let's look at question 4. I mean question 3. Let's try this, right? So we get affected by GCF first. On both top and bottom, affected by GCF. And after that, affected difference of two squares on top, trinomials on the bottom. Okay, let's try it. Oh no, actually. Okay, so let's go over solution. So on the top, we're going to factor by GCF. So both numbers are even numbers. 2, right? 2 is the GCF. On bottom, it's also GCF is also 2. So once we factor out the 2, and we get 4x squared and 25. On the bottom, factor out by 2, we get 2x squared plus 5x minus 25. And at the top is the difference of 2 squares, because 4x squared is 2x squared, and 25 is 5 squared, right? So it becomes 2x plus 5, 2x minus 5. The bottom, we just going to factor trinomial, right? 2x and x, that's the only way to break down 2x squared. On the right, now we get 25, right? Got to be 5 and 5. Because it's minus, so one of them got to be minus, right? This one's minus, this one's plus. Because when we cross multiplying, we're going to get 2x times 5 is equal to 10x. And then negative 5 times x is minus 5x. The difference is equal to 5x. That matches the middle term. So the first term here, last term, and middle term. All confirm. They get 2x minus 5, x plus 5. Now from here, we cancel the common term, right? Common factor, station. Cancel the 2, and end up with the 2x plus 5 over x plus 5. Any question about this? So the answer is 2x plus 5 over x plus 5. Should be correct answer. Now, the last question here, let's try it. Again, factor by factor trinomials. Let's give it a shot. Okay, let's go over the solution. So factor the top. So break down 2x squared is 2x. It's the only way to break down, right? And -9. So we need to get positive 3x in the middle, right? So up 3 and 3 here. Multiply, you get -9. When you cross multiplying 2x times 3, positive 3 is positive 6x. Minus 3 times x is -3x. Combine them, we get positive 3x. That means it's correct factoring 2x minus 3, x plus 3 on the top. And on the bottom, very similar, right? Break down 2x squared, 2x times x. But again, we're going to break down as 9 positive 9 as -3 and -3. Multiply them and get positive 9, right? Let's cross multiply to check the middle term. So 2x times -3 is -6x. -3 times x is -3x. Combine them and make it -x.
If you're writing something, we can't see it.
Oh, I didn't share. Sorry. Yeah. Okay, so thanks for the reminder. So this is I did write a lot. But here you go. So first of all, when we factor the top, then you get 2x x. Break down -9 as -3 times by 3. And we cross multiplying, you get 6x minus 3x, which is by 3x. That's for the top. On the bottom, and break down 2x squared, you get 2x times x. And break down positive 9x, -3 times -3. And when we cross multiplying, we get 2x times -3, -6x. -3 times x is -3x. Combine those to get minus that x, which is the middle term. So all three terms are confirmed. And we get 2x minus 3, x minus 3. And now from there, we cancel the common factor. Only when you multiply, right? You can cancel. If it's adding, then you cannot cancel, right? That's the thing. You gotta be careful about this. Only multiplying, you can cancel. So it will be x plus 3, x minus 3. Any question about this? Okay. Good. So let's go back to the answers here. Top x plus 3, on the bottom x minus 3. That's correct answer. Okay, so that's everything on section 7.1 on the syllabus. On my course schedule, chapter 7 only require this section. So we're gonna move on to chapter 8. We're gonna cover just 3 sections, and some of them very basic stuff, so it's I think like grinding together.
Wait, so for chapter 7, we only need to do that first one?
Yes, whatever I
Okay.
assign, right? That's your work. Yes, and it's only required even in the regular semester. I've taught this like about 10 years ago, so it only requires section 7, right, in the basic algebra course. You're gonna learn the rest of them in the intermediate algebra course, which is next level. Okay. Yeah, so now let's take a look at chapter 8. Chapter 8, it's about the square root, mainly about square root. About roots, right? But we focus on the square root. Yeah, so square root. And section 8.1, basically it's on a Pythagorean theorem. Pythagorean theorem. I'm gonna go over Pythagorean theorem and show you where this comes from, the root comes from, and also the relation, the common roots and the common roots. let's start with the Pythagorean theorem. So basically you have a right triangle here. Let's say we get a right triangle here. And that's so there's a relationship, right? Let's say this is the angle alpha. And this is A, this is B, this is C, right? And there's a relationship C squared equal to A squared plus B squared. And this is basically the Pythagorean theorem. And then the root, the square root was originated from this Pythagorean theorem. I'm going to show you an example. You'll see how this goes, right? Let's say example 1. Say right triangle here. And then we know this is 6 feet. Let's say 6 feet. This is 8 feet. Right? Let's say you want to figure out this is a vertical building. You want to figure out what's the side of this building here. You want to figure out what's the length of this side, right? And you want to find out what is C here. If the base is 6 feet, the height is 8 feet. What would be this? The hypotenuse of this hypotenuse of angle alpha, right? So we set up the Pythagorean theorem. So C squared will be equal to A squared. A is 6, right? A is 6 here. And B is 8. So it's A squared plus B squared. And we replace both A and B with a given number. So we get 6 squared plus A squared. C squared will be 36. That is 64. And C squared equal to 100. Okay. Then one number square equal to 100. Any suggestion? What do you think? What square equal to 100?
Is it 10?
Yes, very good. Exactly. So C equal 10. How about negative 10?
You said negative 10?
Yes, how about is negative 10 squared equal to 100? It is, right? So actually you
Yeah,
have
because
to
it's like
answer.
the absolute,
Right, exactly. So
yeah,
the
the
idea
absolute
is,
value.
that's right. So actually the answer will be plus minus. And then it comes from the square root, right? So basically you're taking the square root from both sides of the equation. And on the right-hand side, we put plus minus. Because we're going to end up with the two solutions here. Okay, this is where the root comes from, right? This why people the mathematicians invented root to help us understand some geometrical shape and the geometry and also trigonometry, right? Eventually, this is a foundation for the trigonometry you're about to learn in intermediate algebra. So C is equal to plus minus. That's why we know square root of 100 is 10. How is that? You're going to do this, right? Because 100 equals 10 squared. And this is square root. The index is 2. This square cancel each other. Right? The root and then the square cancel each other. And you end up with a 10. This is another way of looking at this, the result. But we are in the real world, right? So the C cannot be negative 10. It's not applicable in the real world. C must be 10 feet, right? We don't know what is negative 10 feet, right? Nobody knows what that is. It doesn't make sense, right? So that's why it has to be at 10 feet. It's not defined in our world, right? Maybe in another universe or maybe in different planet, another planet, but not in our planet. Okay, so C equal 10 feet. Okay, any question about this?
Yeah. So you
Okay.
saw how we got
Mhm.
C squared equal 100. How
Yeah.
do we know like to always find the square root? Because at some point we'll just be like 10 squared equals 100 and leave it at that. Like some people just make that mistake. So how do we decipher like always trying to find the square root?
Uh,
till I get the
Can I
simplified
answer
answer.
it? Can I
Yes,
answer his
yes,
question?
please. Yes, go ahead.
So as long as there's like the two, because you see how C squares there? Like there's the two above the C, right?
Mhm.
So that always means that you have to find the square root because it says C square equals 100. Now, what is C by itself equals? You get it? So like, let's
Yeah.
say it says C square equals, what's another quick one? 25? What
Yep.
is the square root of 25? 5. So
Yeah,
you do C
exactly.
equals 5.
Right. Very good.
As long as there's a 2 above the C, it could go smaller. Think of it
Uh,
that way.
all right, thank you. That really helps. Yeah, I
You're
appreciate it.
welcome.
That's great. Yes. So we help each other out. But yeah, so mathematically speaking, right, the root was created to tackle this type of problem. So how to reduce the power to get rid of the power here. Right? It's just like sort of get rid of the power. So you have to apply the root to offset the power. That's the essence of this. So the root is used to offset the power. And then in order to simplify this, in this case, you see, I show you square root of 100. It could be written as square root of 10 square, right? Square root and then square offset each other. Square root and the square. Offsetting each other, right? Offset each other. I think I'll just use the word offset each other. Or cancel each other. That's another way of saying that. It cancels each other. Cancel each other. So that's why this is our goal, right? So we can end up with a 10 minutes. Cancel each other. And this is basically how we help mathematicians create a square root at the very first place, is to help us understand some of the real world phenomena. And now let's look at some of the common roots. Okay, let's start with I think that you guys mentioned 25, right? So let's put all the roots together, all those common roots. Common square root, right? I'll put it more specific. We have cubic root, right? All those different common root. Square root first. And we are only required to work with the square root, that's all. So first one is the square root of 1. It's 1, right? Why is that? Because this is square root of 1 squared, and then square and the square root. By default, right, there's a 2 here. They cancel each other, so that's why it's 1. Also, square root of 4, it's 2. And all those numbers we call perfect numbers. So there's a list of the called perfect numbers. I like to have 1, right? 2 square, 1 square is 1, 2 square is 4, 3 square is 9, right? 4 square is 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, right? And then 100, 10 square 100, 11 square 121, and then 12 square 144, and then 13 square 169, 14 square 196, 15 square is 225. The list keep going, right? We have infinite many perfect numbers, and all of this root becomes a special number, right? So square root of 4 becomes 2, square root of 9 becomes 3, and square root of 16. So you go back to the, like 16 is 4 square, right? So you go back to the base number here. So we all go back, right? This is 5 square, right? And then 6 square, and then 7 square, and this is 8 square. So the answer is all going back to the base. So here is 4, right? and square root of 25, it's 5. Yeah, so those are first 5, and square root of 36, and that is, okay, I'm going to erase this. I'm going to put it in a proper order, so you see everything here. This is the first row here, and MS square root of 36, it's 6, square root of 49, that is 7, square root of 64, that is 8, square root of 81, that's 9, square root of 100, that's 10, square root of 421, that's 11. We can keep going, right? We can keep going non-stop, you know, 12, square root of 169, it's square root of 13 squared, so outside each other, and that is 14. Square root of 196, it's 14. Square root of 225, it's 15, right? And we can keep going, but we don't need that, right? This should be sufficient for now, you know. Next number will be 256, all that, but we can, it's okay, we can stop right here. Those are the common square root we can use. And sometimes we need to simplify things, right? For example, let's get to the common properties of the, maybe before, yeah, let's get to the common properties. But do you have any questions so far about this common square root? Okay. And this is useful, right? So keep that in mind. All the perfect numbers, when we take in the square root, it becomes the base. Now let's look at some of the properties. So this is 8.1, 8.2. It's on the properties of radicals. And we're going to simplify some of the radical expressions using the properties of radicals. And let's start with the what we call the property number 1. It's like breaking down the let's say we have a square root of xy, right? Like the breakdown is square root of x and square root of y. So here we're gonna make sure x is greater than 0, y is greater than 0, right? Because this is square root. By definition, whatever under square root must be greater than 0, and greater equals 0. Greater equals 0, that's it. And let's apply this property to simplify some things, right? I'm going to show you a couple of them. Okay, so start with the first one, square root of 20. Now, how do we break down 20? So this is the key question here. So we got to go back to all these perfect numbers, right? So you're going to go through the list. Look for the maximum perfect number that goes into 20. In this case, it's going to be 4. So that means you're going to break down 20 as 4 times 5. Not 2 times 10, right? 2 is not a perfect number. So you're going to do perfect number times another number. 4 is the largest perfect number or maximum perfect number that goes into 20. That's why we do 4 times 5. Now apply this property here, becomes square root of 4 times square root of 5. And we know what square root of 4 is, right? It's 2. It's a perfect number, right? So that's why 2 radical 5. And that's how we simplify this radical expression. Any question about this? Second one is square root of 75. So now, what will be the maximum perfect number goes into 75? Any suggestion?
Is it 9?
Nope.
No, not 9.
75.
6. No, wait, hold on. Because 9 times 9 is 81.
Yep.
So it would be
How
8?
about no? How about 25? 25 times 3. 25 is
You want to do 25?
huh?
You said 25?
Yeah, 25 times 3, right?
Okay.
25 is a maximum perfect number that goes into 75. So that's why it gotta be it gotta be 25 times 3. So we get the square root of 25 times square root of 3. And square root of 25 becomes 5. 5 square root of 3. That's why I always look for the maximum perfect number here. Oh, 5 going to 75, right? Because this number ends with 5, so you should always think about the 5 or 25, all those kind of numbers. If it ends with a 0 or 5, right? That's usually the case. But in this case, 25 with the maximum perfect number goes into 75. And that's why I break down as 25 times 3. And square root of 25 is 5. And that's how we simplify to those terms. Now let's take a look at some of the okay, let's look at the let's see. Let's say we get square root of 25 x cubed. Okay. Now again we're gonna simplify this, right? And 25 is already a perfect number, which is good, but x cubed is not a perfect term. So break down x cubed as 25 times x squared times x. Now, as you can see, what is square root of x squared? It's actually greater than 0. Square root opposite each other, right? So we know that. That means this one should be square root 25 and square root x squared and square root x. Square root 25 is 5. Square root x squared is x. And then square root x under the root, right? That one we cannot simplify. We leave as is. Okay, and then fourth one, let's look at this. Say we get 18, so 18 times y to the third. So first of all, 18 is not a perfect number, right? So you will break down as the maximum perfect number goes from 18, it's going to be 9. Right? 9 times 2 is 18. And 9 is a perfect number. And then y to the fourth, we're going to write it as y squared squared. Now we're going to split out, right? So 3 different roots. Square root of 9 times root of 2 times root of y squared squared. And again, root of y squared squared, square root, and then the square cancel each other, and that with the y squared. All right, so now we get the square root 9 is 3 radical 2 times y squared. Any question about this? All right, next one. Let's say we get a 3 times square root of 32. Now, 3 is the coefficient in front of the root, so we just carry over that. What will be the maximum perfect number going to 32? Any suggestion? 4 going to 32, right? 4 is a perfect number, however, it's not best one. It's not the best one. We will use 16, right? Although 4 works, but we don't want to use 4 because it's not the largest or the maximum perfect number goes into 32. In this case, we will use 16. 16 is a perfect number. Also, it's a maximum perfect number that goes into 32. In the square up, right, as a square root of 16 times square root of 2. And square root of 16 is 4. So 3 times 4 and square root of 2. That's 4 square root of 2. Any question about this? Find the property, you can simplify. Now let's try some, right? You guys try some. See if you can tackle this type of problem. First one, so 54 simplify. Second one, square root of 24. And third one, 3 times square root of 120. 3 times. And 25. And the fourth one, the root of 64. That's two. Let's give it a shot. And let's go over solution. So before, yeah. So let me put down this property, right? This is also an important property. And my square root of x squared will be x, right? Assuming x is greater than 0. Also, another way of looking at this, right? Let's say if this x, you want to turn it into, it's not a even power, right? If it's r power, then let's say square root x cubed, right? Becomes square root x squared minus square root x. You're going to be x times square root x. So that's actually how you tackle this kind of a, probably number 2, maybe. So now simplify here. Maximum perfect number going to 54. Anybody figure out that? What will be the number? 9, right? 9 times 6, 54. 9 is the maximum perfect number.
Okay, I did that. I wasn't sure if I was right. Okay.
No, that's right. Yeah, it's perfect. So 9 going to 54 6 times. And then 9 is the maximum perfect number going to 54. After that, we apply property number 1, split up, right? Radical 9 times radical 6. Radical 9 is 3, so it's 3 radical 6. And then for 24, what's the maximum perfect number going to 24? Is it 4 and 6, right? 4 times 6 is 24. And then 4 is the maximum perfect number going to 24. It's going to be square root 4, square root 6. Square root 4 is 2 square root 6. That's the answer. And then the third one, again, maximum perfect number goes into 125. It's going to be 25. 5, right? 25 times 5. So 3 times square root 25 times square root 5. Square root 25 is 5. And square root. So 3 times 5, that's 15. Square root 5. Okay. And the fourth one, so we're going to split up, right? And then here, x cubed, we're going to turn into x squared times x. So 64 times x squared times x. And then this one becomes x. Right? So here we go. So we get square root of 64 and square root of x squared and square root of x. And the first two is the perfect number and the perfect term. Square root of 64 is 8. Square root of x squared is x, according to this property. And then square root of x remains. So it's 8x and square root of x. Any question about this? And then property number 3. Let's look at property number 3. And if it's quotient, let's say we get a square root of x over y. And here it becomes square root of x over square root of y. Now assuming x is greater than 0 and y is greater than 0. Meaning that it's defined, right? They're both defined. So now let's take a look at some of the examples. Example 1. Let's say we get a square root of 49 over 81. So according to the property, it becomes square root of 49 over square root of 81. And square root of 49 is 7. Square root of 81 is 9. Right? So 7 over 9. Second one, let's say we get a square root of 81 over 16. Very similar, right? Split up as square root of 81 over square root of 16. They both part the numbers. So square root of 81 is 9. Square root of 16, that's 4. Now we'll see. And now let's take a look at a little bit more sophisticated ones, right? Let's say we get square root of 50 over 49. First of all, we will split up as square root of 50 times square root of 49. So from here, for 50, we're going to break down as 25 times 2. Maximum perfect number going to 50 is 25. And we get square root of 25 square root of 2 over square root of 49. And square root of 25 as 5, square root of 2 over 7. Any question about this? So it's like keep breaking down, right? Using the property to breaking down and using all the common roots to simplify. The fourth one, let's say we get 12 cube over um, over let me think of a number, right? We better use, let me see which number we better use. $121, let's say. Okay. Now, again, we're going to split up, right? On the top, it becomes 12 times x cubed. On the bottom, it's 121. And 12 is not a perfect number, so we're going to split up as a maximum perfect number times another number. And so in this case, 4 is the maximum perfect number going to 12. So it'll be 4 times 3. For x cubed, what is it did, right? It will be x squared times x. On the bottom, it's 121x11. On top, two couple perfect number, perfect term. So it will become radical 4 times radical x squared. And the other two terms put into the same radical, right? You go 33x to 11. And simplify. So square root of 4 is 2. Square root of x squared is x. And square root of 3x over 11. And so that's how we simplify. So basically put all the remaining terms, right? All the remaining terms inside the radicals and leave as is. Yeah. Any question about this? Right. Let's try one more. A little bit more sophisticated ones. Let's say we get a square root of 32 x squared y cubed. Right? And the bottom is 49. Something like that. Okay. So we're going to apply the property 1 and property 3, and probably also property 2, right? One by one. So 30 for 32, the maximum perfect number going to that will be 16. 16 times 2 is 32. X squared is a perfect term. Then y cubed, we're going to split it as y squared times y. Y squared times y squared. Y squared is a perfect term. And y. On the bottom is just going to be 49. We square root of 45. Now we get 3 perfect terms, right? This one is a perfect number, perfect term, perfect term. And the other two goes into one root. So we get square root of 16 times square root of x squared times square root of y squared times square root of y. On the bottom, that's 7. And square root of 16, that's 4. Square root of x squared is x. Square root of y squared is y. And square root of 2y over 7. That's basically how we simplify these radical expressions. Any question about this? Okay, you guys try some of them, right? I'm gonna show you a couple and try it. So let's try what is a square root of 125 over 64. Second one, what is square root of 75 over 9? And the third one, what is the square root of 54 a squared over 25? Fourth one, this is the square root of 72 cubed y squared over 144. What that's 944. 169. Okay, let's try this. All right, guys, let's go over the solution really quickly. Right, so first one, we're gonna break that as first one split up as 145 over square root. And for 125, it's gonna be 25 times 5. The maximum perfect number goes into 125 over 25. And square root of 25, so 5 over square root 64. So 25 is 5. So it's 5, so 5 over 8. And second one, very similar, split up by 75, square root of 75 over square root of 9. So square root of 75 equals 25 times 3. And square root of 25, that's 5. And square root of 3 remains over 3. And the third one, very similar, maximum perfect number going to 54 is going to be 9. That's 9 times 6. That's 8 squared over square root of 25. Square root of 9, square root of 8 squared, square root of 6, right? Or we just keep with the same order here. We don't have to change it. Square root of 6, square root of 8 squared. On the bottom, square root of 25, that's 5. Square root of 9 is 3, square root of 6, square root of 8 squared is 8 over 5. Okay. And then the very last one. So read the 72 as 36 times 2. 36 is the maximum perfect number that goes into 72. X cubed will be x squared times x to the first, y squared. On the bottom is square root of 169. Square root of 169 is 13. Now for all the perfect term, right? 36, square root of x squared, square root of y squared together, separated, like 3 different roots, and we put 2x together. 2 and x remains, right? We get the radical. So square root of 36 is 6. Here's the x, that's y, and times square root of 2x over 13. Any questions about this? Okay, so now let's take a 30 minutes break. Come back at 10:46. I'll talk to you in a second. Okay, guys, let's resume. Right? We just finished that topic. Let's take a look at home assignments. Let's go to the 8.1 home assignments. The definition common roots. Okay, question 1. Let's simplify this, right? Anybody have an answer for this? What is square root of 225? No, nobody knows. Okay, so the answer is 15. Square root of 225 is a perfect number. And how about square root of 100 x to the 6, right? You guys try this one.
Why it gotta get so difficult bringing in the square to the 6, the x to the 6? Why couldn't they just leave it alone with the 100?
Oh, that's an interesting one.
Jeez.
That's how you that's how you become better, right? You know, you don't want to just work with the x squared all the time, right? You want to get
Yeah.
better and better, become better and better, right? That's the whole thing.
Listen, they need to give us a couple of months before they start wanting us to get better.
I know, but you should learn this in the high school.
I mean, I don't remember. Y'all talking about this is all elementary math. I
Yes.
don't remember half of this stuff.
Uh,
Once we got to like the square root stuff and the elimination thing, I really didn't remember any of that. I'm like, and then you got me counting sixth and seventh grade. Nah, I definitely didn't do that.
okay, so your previous teacher probably skipped the topic, but that's not good. They should already teach you guys this. And this is kind of like all of this algebra and pre-algebra stuff, right? You should learn this at least a couple times in the junior high school and high school. That means, they probably didn't do a good job teaching you guys this. But that's why, you end up in this program. But it's good, this program is very good, You don't have to spend the entire semester just reviewing all these contents. You can knock it off and then move on to the regular math class, like not non-remedial, right? Credit-bearing course, like statistics or pre-calculus. But you don't take pre-calculus, you need to pass 56. So, but again, it's okay. Although they didn't teach you this in the high school, no problem. You can learn it right now. It's okay, right? Okay, give a shot about this, right? Try it. Okay, let's go over the solution. So it was split up as a square root of 100 times square root of x plus 6. And then x to the 6, if you rewrite it as x cubed times x cubed, right? It becomes x cubed squared. And we know that if it's a square root of x squared, right? It becomes, so very similar here, it would be square root of 100 is 10, and then square root of x to the 6 will be x cubed. So 10x cubed. That's the answer. Any question about this? Yeah. Any answers? This is correct answer, and then let's look at the next one, cubic root. Okay. Yes. So I'm going to show you how to solve this cubic root since it's appearing here. So cubic root, any root, right? I'm going to show you a general method. Let's say you get any root, cubic root, fourth root, or like squished root, everything like that. That's a general property used to solve this. Let's say this root is nth root. I'll get x to the a and y to the b. So the easiest way to do this is basically do this. Using exponent a divided by index a. Same thing for the b, for y, right? You do the b over index n. And here we're assuming x is greater than 0, and then y is greater than 0. So applying this property here, so this applies to any root, right? This is a universal property. In this case, for x, you do 12 divided by 3. For y, you do 12 divided by 3. Now we simply get rid of the root by using the exponent divided by the index of the root. So it becomes x to the 4 and y to the 4. Any question about this? And this property is very useful, right? Later on, you can even convert, like, say, for example, like something like later you learn in this higher level math class, like calculus class. You need to do this. You using the power divided by index. So we turn this into the exponent. All the root could be turned into exponent, right? By using the general property here. So this is very useful property to do the conversion. So going back here, you do x to the 4th, and y to the 5th. And you submit it, you get a correct answer here. It's good. And then let's look at the, so still right cubic root of 8. Yeah, so I'm gonna show you how to do this as well. And maybe you try this. Maybe you guys try this. Just turn everything to the exponent, right? Turn the 8 as the exponent. Will be 2 times 2 times 2. Then we get 2q. Now apply that property I just showed you. Let's say nth root, x to the a, y to the b, times x, a over n, and y b over n. Now you try this, see if you can end up with the correct answer. All right, let's go over solution. As I mentioned, we turn A as 2 cube. We get cubic root of 2 cube. And then x prop. I'm gonna do this. 3 over 3. Using this property here. X 12 over 3. And this becomes 2 to the first. Times x to the fourth. That becomes 2x to the fourth. Yeah, so that's how you simplify this.
Professor, you're gonna be proud. I got that answer.
What is it?
I got that answer. You're gonna be proud.
Yeah, of course. You're gonna be proud because you learn how to solve it. Yeah. Yeah. So so 2x to the fourth. Let's check the answer. So 2x to the fourth. So the answers is correct, right? Now let's move on to 8.2. Although it's a label 8.1, but actually it's 8.2. I think the labeling it's incorrect here. So you do see 8.1, but one of them is 8.2. The one we're about to go over, right? Property of radicals in the textbook it was 8.2. And let's take a look at some of the questions here. Let's start with the simplifying square root of 27. Right? You try it very quickly. Also, let me quickly just give you some of the basic cubic root, right? Since we have some kind of like cubic root stuff here. So cubic root of 1 is 1. And this is all the perfect cube number, right? Perfect cube number. Start with 1, and 2 cube is 8. 3 cube is 27, right? 4 cube is 64. 5 cube is 125. 6 cube is 216. And 7 cube, 7 times 7 times, so 49 times 7, that's 343. Right, those are the perfect 8 times 64 times 8, 512, right? And so these perfect cube numbers, it all comes from this 1 cube, right? This is 1 cube. This is 2 cube, 3 cube, 4 cube, 5 cube, this 6 cube, and this is 7 cube. So we
So
end
is
up.
the answer 3?
Hmm?
So is the answer 3 for this problem?
No, this is not cubic root. This is square root. I'm just gonna review some of the cubic root with you for now. So cubic root of 8 is 2. Cubic root of 27 is 3. And cubic root of 64 is 4, right? And these all come from this general properties of the cubic root of n root of x to the a, right? Because x, a over n. So that's the cubic root of 125, that's 5. The cubic root of 216, 6. Cubic root of 343, 7. In this case, what do you think? It's a square root, right? It's not cubic root. So it'll be 9 times 3. So we get a square root of 9 times square root of 3. 9 is the maximum perfect number that goes into the 27. So square root of 9 is 3 square. So the answer is 3 square root in for this particular problem. 3 square root, we get a square root on the side. So the answer is we got 3. That's correct answer. Now let's take a look at 252. You try the square root, right? This is square root. Only for the square root, you don't see the index here, right? But by before, we don't see any number here is a square root. But anything else like cubic root, fourth root, you will see it. They'll put it on the side, right? Let's see, fourth root of 16. They'll put this index on the side. All right, let's go over the solution. So first of all, you're going to break it down, right? The maximum perfect number going to 252 will be 36. But if you cannot find 36 right away, no problem, right? Use 4 first. 4 going to 252, that's 63. Now we're going to continue breaking down 63, right? Because 9 is the maximum perfect number going to 63. So it will not. Basically, you just break down. If you do not see 36 right away, but if you see 36 right away, then use 36. That's better. So square root 4, and square root 9, and square root 7. Square root 4 is 2, square root 9 is 3, and square root 7. 2 times 3 is 6, square root 7. Okay. Any question about this? Answer 6, square root of 7. So maybe answer is good. And let's try this one. we did something similar earlier. So break it down as a perfect number, perfect term, and remaining terms. Okay, let's go over the solution. So the maximum perfect number going to 28, it's gonna be 4, right? 4 times 7. And for excellent ninth, we break down as extra eighth and extra first. Always break down as an even power than the other one. And so here we can do this. We can do square root of 4, square root of x to the eighth, and then square root of 7. Square root of 4 is 2, right? Or you can do square root of 2 square, right? Square root of 4 equals to square root of 2 square. Then we do 2, 4 over 2. That becomes 2 to the first. Same thing for x to the eighth, you do x a over 2. So this is 2 here, right? Index is 2. Then we carry over square root of 7x. So we get 2x to the fourth times square root of 7. Any question about this? 2 x to the fourth. That times square root of 7x. So we answer, we get this. It's correct answer. Next problem. Let's try this, right? 3 terms. Try this really quickly. Yeah, let's go with the solution here. So start breaking down 45 first. So the maximum perfect number that goes into 45 will be 9. That's 5. Then for absolute 9, we break down as x8 times the first. Y to the fourth is already a perfect term. Now we can so keep these two right in one root. So square root of 9 times square root of x to the 8 times square root of y to the 4th. Now times square root of 5x. And square root of 9 becomes 3. Then x to the 8 and put back in that a over 2. So that's going to be 8 x to the 4th. The y very similar. We do y 4 by 2. So y squared and square root of 5x. So the answer is 3x to the 4th y squared times square root of 5x. Any question about this? 3x to the 4th y to the 2nd square root of 5x. That will do it. It's the answer. Next one. Okay, let's try this one. You guys try this one first. Okay, guys, let's go over the solution here. So first of all, break down as square root of 63 x to the 7 over square root of 4y squared. On the top, so maximum perfect number going to 63 will be 9. So 9 times 7, x to the 7 is the 20 as x to the 6, the x to the first. On the bottom, it will be square root of 4 times square root of y squared. I will get square root of 9 times square root of x to the 6 times the other two, right? Keep it under the same root 7x. And for the denominator, I get square root of 4 is 2. Square root of y squared is 1. And right here, square root of 9 is 3. Square root of x to the 6 is x to the third. Square root of 7x over to 1. Any question about this? So we put an answer there. 8.1 equal to question 5. So it'll be 3 x to the third minus square root of 7x. And put this in the divide. Okay. So put the whole thing in the parentheses and dividing by 2y. Yeah, so that should do it. Submit the answer. It's correct answer. Okay. Now let's move on to section 8.3 on basic relations with radicals. So now let's look at how we add and subtract radicals, right? So let me go back to the note. Now we start with the addition and subtraction of the radicals. So here 8.3 called basic operation, but we mainly focus on the addition and subtraction, right? Basic operations with radicals. Addition, subtraction, multiplication, division. Those are the basic operations with radicals. So start with the addition and subtraction, right? But before we do that, let me just go over some of the properties we already went over earlier, but it's kind of like reverse properties we talked about earlier. Properties. Yeah, so first one is we look at the square root of 8 times square root of b, right? We turn into 1 square root of b. Secondly, we look at the square root of 8 over square root of b. We turn into single square root a over b. The third one, we look at the square root of a times square root of a and the square root of a squared. And square root offset each other, so get 8. Those three are the properties we're going to need. Tackle some of the problems here. And going back to the addition and subtraction of the radical expressions. First one is 3 radical 5 minus 7 radical 5. And because they have the same radical 5, we call this like fraction, like terms, like terms. Meaning we can treat radical 5 as like x, right? It's like 3x minus 7x. Or you can factor out that. We get put a radical 5 outside. And we can subtract the coefficient 3 minus 7. So that's how you combine like terms, right? Similarly, let's say we get a 7 radical 2 minus 3 radical 2 plus 6 radical 2. Then we're going to have a 7 again, factor out of radical 2. So 7 minus 3 adding 6. Times radical 2. 7 minus 3, that's 4, adding 6 is 10 radical 2. Okay, so just adding and subtracting the coefficient. The third one, let's say we got 3 radical 50 plus 3 times, right? It's not 3, it's 3 times square root of 50 times 2 times square root of 32. If you look at 50 and 32, they are not like terms, but we can simplify. First, 25 is the maximum perfect number going 50. We do 25 times 2 here. This one, 16 is the maximum perfect number going to 32. 16 times 3. From there, we just simplify, right? Square root of 25, that becomes 5, and square root of 2. The other one is square root of 16, and square root of 3. And this one becomes 3 times 5 times square root of 2. This one becomes 2 times 4 times square root of 2. So 3 times 5, that's 15. So 2 plus 8 square root. And they're like fractions right now. So keep the square root of 2, adding 15 and 8, you get 23. Yeah, that's basically how you simplify this type of expressions and add and subtract. Right. And let's say another example, here you get 8 times square root of 12 plus 5 times square root of 3a squared. But again, we're going to simplify each one separately and then try to combine our terms. So here a carry over a, and for 12, the maximum perfect number going to 12 will be 4 times 3. Another one, so radical 3 and radical a squared. A squared is a perfect term. So square root of 4 becomes 2, so it's 8 times 2 times square root of 3 plus 5 square root of 3a. So it's 2 square root of 3a plus 5 square root of 3a. Now they are like terms, right? Both have a. So combine 2 square root of 3 plus 5 square root of 3, and that becomes 7. Adding 2 and 3, you get 7 square root of 3. Any question about this? Okay, so now you guys try some of this. First one, 11 square root of 11 plus square root of 11. Let's see what that is. The second one, you get 5 square root of 20 plus a square root of 80. And in the third one, 5 square root of 3a squared minus a square root of 3. And let's go over the solution. So here, that's the invisible one in front of the square root 11. So we're adding 11 and 1. Get 12, square root 11. And the first of the square root 11, adding 11 and 1 gets 12. Second one, the maximum perfect number going to 20 will be 4. It's fine. For the other one, 80 will be 16 times 5. And then square root 4 is 2. Square root 16, that's 4. So this first one is 5 times 2. Square root 5. Second one, 8 times 4 is square root 5. 5 times 2, 10 square root 5 plus 4 times 8 is 32 square root. Now keep the radical 5 and add those two numbers. 10 plus 32 is 42 square root 5. Yeah, any question about this? And then the third one, square root 8 squared is 8. 8 times square root 3. 5 times square root 3. Square root 8 squared is 8. The other one is square root 3, 8. Just rearrange it. And here this is actually 1 square root 3, 8. That's 5 square root 3, 8. So subtract it, right? So 5 radical 3 minus 1 radical 3. For the 8 outside, and we subtract the coefficient 5 minus 1 is 4. 4 radical 3, 8. Any question about this? So yeah, that's the answer for this, right? So that's how you add the subtract radicals. Now let's take a look at how we multiply and divide radicals. Start with the multiplying. Multiply and divide. Again, we use some of the properties. We have the one. If you just purely multiply, let's say 3 radical 5 times 2 radical 7. And you multiply the number, right? So 3 times 2 gives us 6. And then you multiply both radicals. 5 times 7, that's 35. 6 square root 35. Yeah, that's the first one. Second one, you get the square root of 5 times square root 2 plus square root of 5. So very similar. We just distribute it. Radical 5 times radical 2, that's radical 10. You multiply 5 and 2, right? You get 10. The other one, radical 5 times 5, that's radical 25. Radical 25 is 5. So the answer will be radical 10, radical 5. So distributing, and we simplify afterwards. Third one, let's say we get the radical 5 plus 2. And radical 5 plus 7. So FOIL this, we call this FOILing. So radical 5 times radical 5, that's radical 25. And radical 5 times 7, that's 7 radical 5. 2 times radical 5, that's 2 radical 5. 2 times 7, that's 14. You combine those two, radical 25 is 5. Combine the middle two terms, 7 plus 2 is 9, radical 5. And adding 14. Now add 5 and 14, it's 19. So it's 19 plus 9 radical 5. So it's part 3, part 4. Radical 8 plus radical B. times radical A minus radical B. You can also treat this as A plus B, A minus B. So it's A squared minus B squared. Or we can also FOIL, right? So okay, radical A times radical A first. Radical A squared. And the second term will be radical A times negative radical B. That's minus radical AB. Now we multiply radical B and radical A, both positive, and get radical AB positive. Now radical B times radical B, negative radical B, it's minus radical B squared. After that, simplify radical A squared A, middle two terms cancel each other, opposite terms cancel. Minus radical B squared, that's B. So the answer is A minus B. Also, if you use a shortcut, that's going to be radical A squared minus radical B squared, A plus B, A minus B, A squared minus B squared. So the square root A squared is A, square root B squared is B, A minus B. Okay. Same result, no difference. Okay, any question about this? I'm going to show you how to divide, right? So let's look at on a division problem. And then usually when you divide it, then you're going to use this term called complex conjugate to simplify this. I'll show you how. Now basically you're going to apply this property here. This becomes a property. So now let's look at this. Let's say we get something like radical 3 over radical 3 minus radical 2. So in order to simplify this, we will need this term called complex conjugate, or the conjugate. So we get A minus B here, right? A minus B, so we need A plus B. So the conjugate here is going to be radical 3 plus radical 2. That being said, it's going to multiply both top and bottom by the conjugates. So the first, the top one, we multiply radical 3 by radical 3 plus radical 2. And the bottom, we get radical 3 minus radical 2 times radical 3 plus radical 2. On the bottom, it becomes A minus B plus B. Top, we just distributed radical 3 times radical 3 is radical 9 plus 3. And then radical 3 times radical 2 is radical 6. Bottom, this is A minus B, A plus B, so it becomes A squared radical 3 squared minus radical 2 squared. After that, simplify, square root of 9 is 3, radical 6. The bottom of this square root square is square. So square root 3 squared, that's 3. Square root 2 squared is 2. So 3 plus square root 6 over 1. So the answer is 3 plus square root 6. Yeah, any question about this? You guys try some of these questions. Let's see you understand how to simplify this. Starting first one, 2 radical 3 times 5 radical 7. Second one, we got square root x plus 3 times square root x minus 7. Third one, square root 5 plus square root 2 times square root 5 minus square root 2. And fourth one, 2 over square root 5 minus square root 3. Try this really quickly. Yeah, let's go over the solution here. 1, let's go to 5, to 10. Let's go 3 times go 7, so 3. And then for the second one, we're gonna FOIL this. Square of x times square of x is square of x squared. Square of x times -7 minus 7 square of x. 3 times square of x, 3 square of x. 3 times -7 minus 21. And after that, we simplify. Square of x squared is x. Minus 7 adding 3 is minus 4 square of x. Minus 21. And the third one is a difference of two squares, right? So a plus b, a minus b. So it's a squared minus b squared. Square of 5 squared is 5. Square of 2 squared is 2. 5 minus 2, that's 3. And the fourth one, conjugate. Get a conjugate. Radical 5 minus radical 3. Adding, right? Adding. So we would just multiply both top and bottom by radical 5 plus radical 3. So on the top, radical 5, radical 3. On the bottom, you can get radical 5 plus radical 3. On the bottom is a difference of two squares. Carry over the top, radical 5 plus radical 3. On the bottom, so we will end up with a radical 5 square. This radical 3 square. The square root square offset each other. And we end up with 5 minus 3. Square root 5 squared is 5. Square root 3 squared is 3. And that gives us 2. 2 times radical 5 radical 3 over 2. And after that, we cancel the 2. So the answer is going to be radical 5 plus radical 3. Any question about this? Okay, so now let's go back to the workbook. Let's look at some of the home assignments. So 8.4 and 8.5. 8.4 first. Adding, subtracting the radical expressions. Problem 1. So anybody want to share your answer? 4 radical 5 plus 7 radical 5. What's the answer? So you add 4 and 7 to 11. So 11 is for the radical 5.
Is it square root 5? Yeah.
Yeah, that's right. Very good. Correct answer. How about the second one? Anybody want to try that? Ax radical 13 minus 9x radical 13. So you do ax minus 9x, it's minus x, minus 1x, right? And then carry over radical 13. So it's minus x radical 13. Okay. Now next one, yeah, this one you get a simplify, so I let you guys try this very quickly. Simplify first, and then combine like terms if available. Okay, try it. Okay, let's go over the solution here. So first of all, we're gonna break down 245. Let's see, what number going to that? So it's we do 81, right? 81 times, no, it's not. 5. 89 is 5 times 49, right? So 49 is a perfect number. Now for 180, it's gonna be maximum perfect number goes to 180 will be 36. 5. Now for 125 will be 25 times 5. Now we get square root of 45. Then square root of 49, that's 7. I mean, so 7 is square root of 5 minus 6 is square root of 5. Adding 5 square root of 5. If you want, you can factor out the square root of 5. And we get 7 minus 6, adding 5. These are parentheses. 7 minus 6, 1, adding 5, 6. So the answer is 6 radical 5. Any question about this? And so simplify and combine like terms. Question 4. Very similar, right? Let's try it. Okay, guys, let's go over this solution here one more time. So for 12, maximum perfect number going to 12 will be 4. 4 times 3. For 75, it's going to be 25 times 3. And for 27 will be 9 times 3. And square root of 4 will be 2. So it's 2 times square root of 3 minus 8 times square root of 25, that's 5 square root of 3. And 3 times square root of 3. And from here, I will just simplify. 2 times 2 is 4. 4 radical 3 minus 40 radical 3. 3 times 5. 3 times 3 is 9 minus 9 radical 3. 4 minus 40 is minus 36 radical 3 minus 9 radical 3. Now, two negative number, keep the sign. Adding 36 and 9 is 45 radical 3. Any question about this?
Where did you get the 5? Like, how did, so when you do the, in the second row, when you do negative 8 times 5, where did you get that?
8 times 5 is 40.
Yeah, but how did you get, because the things start negative 8, 25 point, the square root of 25 point times 3. How did you get the negative 8 times 5?
Square root of 25 is 5.
Oh, so
Yeah.
you do the square root of the
Square
number.
root first, right? Square root of 4 is
Okay,
2.
okay.
Square root of 9 is 3. So we simplify first before we combine like terms. And also this part, you can also do it this way, right? You can factor the radical 3. All the numbers go in 4 minus 40 minus 9, that works. And from there, just combine the numbers. 4 minus 40 is negative 36 minus 9 radical 3. Minus 36 minus 9 is minus 36 plus 9 is 35. So you get the same answer. That's the exact same answer. So the answer is minus 45 square root 3. Minus 45 square root of 3. Submit it. Next correct answer. Okay, let's try this one. Question 5 first. And then question 6. Simplify each term first and combine like terms. Okay, let's go over solution. First of all, break down the 54 as 9.6. 9 is a perfect number. And for 24, it will be 8 times 3. No, it's not. 4 times 6, right? Not 8 times 3. It's 4 times 6. 4 is the perfect number going to 24. So 4 times 6 squared. For 150, you do 25 times 6 x squared. Now again, simplify as much as possible. So here 6x times square root of 9 times square root of 6. Here we do 3 times square root of 4 times square root of x squared times square root of 6 minus 9 times square root of 25 and square root of x squared times square root of 6. And simplify further, get rid of all radicals if possible. So 6x 3 radical 6. Here will be 3 times 2 times x and radical 6. The last one is 9 times 5 times x radical 6. Again, multiply 6x times 3 is 18x radical 6 and plus 3 times 2 6, 6x radical 6 minus 45x radical 6. Now from here, we just factor radical 6, all the variables inside, combine them 18x plus 6x minus 45x. 18x plus 6x, 24x minus 45x radical 6. 24 minus 45, that's minus 21x. That's radical 6. So the answer is minus 21x is radical 6. Any question about this? So let's look at question 6 here. Okay, let's go over solution here. So first of all, 6x squared, go over that. And bring down 63 as 9 times 7 in x. And we're going to do y squared times y. Y squared is probably 2. For 2y are similar, right? 28 will be break down as 4 times 7, x to the fourth times x to the first times 1. I will simplify. And for all this is perfect term, perfect term, perfect term, perfect term, right? Everything else we're going to put into one radical. So 6x squared, radical 9 minus radical y squared. Last one is radical 7x1. This one, 2y minus radical 4 minus radical x to the fourth minus radical 7x1. From there, we get 6x squared times 3 times y times radical 7x1. And here we get 2y times 2 times x squared. Square root of x to the fourth becomes x squared, x squared of 7x. Now, continue from here. So multiply across, right? 3 times 6 is 18. X squared y square root of 7x1. The other one, 2 times 2 is 4 minus 4 x squared y square root of 7x. Now combine our terms. This is 18 x squared y minus 4 x squared y. And so you can factor out square root of 7x1. So two like terms in the parentheses, 18x squared y minus 4x squared y. 18 minus 4, that's 14. So it's 14x squared y times square root of 7x1. Yeah, so that's the final answer. Any question? The answer is 14x squared y times square root of 7x1. Submitted. It's correct answer. This is 8.4. Now the very last section is 8.5. This is multiplying and then dividing the radical expressions. Start with question 1. And this one, let's do it together, right? 3 times 3 gives us 9. Square root of 5 times square root of 7. 5 times 7, square root of 35. So the answer is 9 square root of 35. Submit it. Correct answer. Question 2. You try this really quickly. Radical 2 times radical 11. So first of all, we multiply radical 2 by radical 11, get radical 0.2. And the other one, radical 2. So get 4 radical 2 times radical 2. Radical 2 times radical 2 is radical 4. Radical 4 is 2. 4 times 2, that's going to be 8. So the answer is radical 22 adding 8. Radical 22 add 8. That's the correct answer. Let's move on to the next problem. Yeah, we can skip this one. Let's move on to a little more challenging one. This one. We're going to FOIL this. Okay, let's go over this. So first of all, we FOIL this. So radical 3 times 4 radical 3, we get 4 radical 9. And then radical 3 times negative radical 5 is minus radical 15. Radical 5 times 4 radical 3 are if 4 radical 15. And then radical 5 times minus radical 5 is minus radical 5 times 5, 25. After that, simplify 4 times 3. Middle two terms are like terms. Combine them. 4 minus 1 is 3. Minus 3 radical 15. Last term, that will be minus 5. And that's 12. Adding 3 radical 15 and 5. 12 minus 5 plus 7 plus radical 15. The answer is 7 plus 3 radical 15. Hey, yeah. Any question about this? So you can go over one more question, which is very similar to what we did. Yeah, this one is similar. See any division one. Yeah, they are very similar, right? So I'm just going to go over this one. We haven't seen this one yet. So what if it's square? I'll do it, but I'll do it. So we can expand it, but you can use the thing I showed you this earlier, right? One way to do this is to do square root x squared. It's like a minus b squared we do a squared minus 2 times a minus b, and then plus b squared. Right? So those are the three terms. Here, versatile a squared square root x squared minus middle size minus 2 times 8 and square root x. After that, adding a squared. Here we get x minus 16 radical x plus 16. So this is the answer, right? X minus 16 radical x plus 64. We can also do this radical x minus 8 times this is equivalent to this radical x minus 8. From here, for this radical x times radical x is radical x squared. And minus radical x times negative 8 minus 8 radical x. Negative 8 times radical x is minus 8 radical x. Negative 8 times negative 8 is 64. And middle two term like terms, this becomes x. Minus 8 is minus 16 radical x, and it's 63. So that's pretty much everything for today. So we will review for the final review tomorrow. So before we end the section, do you have any question?
What's the homework for today?
So after 7.1, 8.1, and 8.4, 8.5. In your homework 8.5, 7.1, 8.4, 8.1, 8.4, 8.5.
Okay,
So yeah,
thank you.
no problem. I see you guys tomorrow then.
All
See
right,
you
Professor, have a
tomorrow.
good one.
Okay. Have a
Excuse
good
me,
one.
Professor, I have a question.
Sure, yes.
So my internet was kind of really bad in the morning.
Uh-huh.
So when you were calling out attendance, I wasn't sure if you could hear me.
Oh yeah, I'm out
So I
to
was wondering.
I'm out to
Yeah.
yes.
All right. Thank you.
Okay, see you tomorrow.
All right. Thank you. Have a good day.
Have a good day.